Okay, thank you everyone for joining our session. So today we've come to our second session for our understanding common approaches to combining data from different sources. So in our data preparation and quality unit, we've now had our first tutorial where we've introduced the main type of tools and techniques that we need to master when working with SQL, in order for us to extract, manipulate data. So now we're going to understand common approaches to combine them. So in today's indicative content, we can see that data is data drives the world by combining data from different sources, where we have now a lot of business intelligence and database management. So this process is also known as data integration, where we're now going to involve consolidating data from multiple sources to provide a unified view. So data integration, we need to understand where our data comes from. And one of these sources are data warehouses, where this is a centralized repository that will now store integrated data from multiple sources. This is now used to support queries and analyze, provide a comprehensive view of organizational data. Methodology that are now going to evolve are going to be ETL, extract, transform, and load, where this process will now involve in extracting data from our various sources, such as our data warehouse, transform them to fit into operational needs. Then we have data marts, where we now have our subset of data warehouse, which is now tailored for specific business needs or departments. Some of the use cases are going to be business intelligence and reporting. Considerations we now have to look into requires significant upfront investment and maintenance. Example for this, we now can see how our SQL is going to extract data from a source database. And also, second example, we're now going to transform data to match our data warehouse schema. Also, we have data leaks, where by definition, a data leak is a storage repository that holds vast amount of raw data in its native format until it is needed for analysis. Some of the methodology we're now going to look into ingesting data, where we now have raw data from multiple sources, which is ingested and stored. Schema on read, where the schema is applied when the data is read and not when it's written. Use case with big data analytics and machine learning. We are going to be the consideration. We're now looking into flexibility in storing diverse data type. And some of the example, we're now looking into complaint, and we're now going to copy the code. data visualization. With data visualization, we're now going to have data visualization abstract, where the data will now come from multiple sources to provide a unified virtual view without moving the data physically. So the methodology involved now have virtual views. We're now going to create virtual tables or views that integrate data from different sources. Then we will also have real-time access, where we're going to provide the real-time access to the underlying data. Use case involved, we now have real-time data integration, and considerations are going to be our low latency and real-time access. Example here, we're now going to create a virtual view to combine data from two different databases. Federated database, we can now see that federated database system is going to integrate multiple autonomous databases into a single coherent system. Methodologies that are going to involve are going to be database links, where we now establish links between different databases to allow queries across them. Consideration, now looking into autonomy of individual databases. So here we have a code example where we're now going to create our database link to another database. And also we can now query the data using our database link. APIs, so with application programming interface, this will now allow different software applications to communicate and exchange data over the internet. So when it comes to methodology required for APIs, we now have RESTful APIs, where our HTTP request is going to request get, post, and put and delete data. So this is the simple manipulation that we're going to be conducting with our RESTful API. While with a SOAP API, we're now going to use XML-based messaging protocols. Some of the consideration, we're now going to ensure that we have a secure and controlled access of data. So our API mainly have to be secured. That's why we tend to see some of these connection to be more secure, and you see that with the code of HTTPS. So best practice when it comes to data integration, data quality. For instance, we're now going to ensure that we have data accuracy, completeness, and consistency during integration. Data governance, implement policies and procedures to manage our access. Scalability, where we're going to design data integration solution that can scale over the time. Performance optimization, we're now going to optimize our ETL process. Monitoring and maintenance, where we now continuously monitor and maintain our data integration system. So to conclude, we can now say that combining data from different sources is now essential for comprehensive data analysis and informed decision making. Now we're going to explain the need for combining data. So we now know that combining data from various sources is now essential in today's data-driven world. So this process is also known as integration and will now involve consolidating data from multiple sources to create a unified view. So comprehensive data analysis allows us to combine data from different sources, provide more comprehensive insight. An example for this could be integrating sales data from different regions, which can now help a company to identify global sales trends and performance patterns. Improve decision making. This will now have, when we have data from various sources combined, will now provide a complete picture and will now allow us to support better strategic and operational decisions. Enhance data quality and consistency. So by consolidating data from multiple sources, will now allow us to have redundancy that can be identified and solved. So example for these, we have integrating customer data from different departments, such as sales, marketing, and support, will now ensure that all the team are working with the same up-to-date customer information. Also, we can now combine data management, where combining data simplifies data management by reducing the complexity of handling multiple data sources. We're now going to streamline process and reduce the time of effort required to access and analysis data. Enhance business intelligence. This will now establish the creation of dashboards and reports that can now provide actionable insight to facilitate our real-time decision making. So, example for enhanced business intelligence, we could have a BI system that is going to integrate data from finance, HR, and sales department, and this can now provide a comprehensive view of our company performance. Increased operational efficiency, where we're now going to integrate data which can be used to optimize workflow, reduce manual effort, and enhance productivity. So example for this, we're now going to integrate data from manipulating, logistics, and sales that can streamline supply chain operation and reduce delays. Competitive advantages. This will now allow access to integrate data, which allows companies to respond quickly to make changes on customer needs. So, example, we can see that a company that integrates and analyzes market trends, customer performance, and competitor activities can develop more efficient marketing strategies. With facilitating compliance and risk management, now we're going to ensure that all our necessary data is available and can be monitored and audited as needed. So to conclude, we can now say that the need of combining data from different sources is driven by the desire of comprehensive analysis. So in our learning outcomes, we're now going to describe the difference between horizontal and vertical appending. So what do we mean by data appending? We now know that this is a crucial concept in data integration, which is basically allowing the combination of data sets in various ways to achieve a comprehensive and cohesive data analysis with horizontal and vertical appending. These are two primary methods used to merge data from different sources. With horizontal appending, this, also known as horizontal merge or union, will now involve combining data sets by adding rows from one table to another. And the key point, we're now going to add rows from one table to another. Is now useful when combining data from similar source or time periods. And it also requires the data set to have the same column structure. Here we have an example of using horizontally append rows from two tables. So the query is now going to combine rows from employee 2023 and employee 2024 table, and is now going to be including only the unique rows. So every duplicate are going to be removed. Vertical appending. This is going to combine in data sets by adding column from a data set to another based on a common key. So the key point is now going to add column from one table to another. It is useful for enriching data by adding additional attributes, and you now requires a common key to join the data set. SQL example, we now can see with the vertical appending column, we're now using a SQL join statement. So this query will now combine columns from the employees table and the salaries table based on the ID column in the employees and employee ID column in salaries. So here we have a summary of what we've covered so far. Here we have a detailed explanation of vertical appending using SQL. So to verify append the salaries table, the employees table, we'll now use a join statement. So to conclude, we now know that understanding the difference between horizontal and vertical appending, it is now very important when it comes to data integration. Here we have some key topics when it comes to data integration. So we have to look at the three-value logic, such as true, false, and null. Where in SQL, the three-value logic is going to ensure that we have three possible truth values. So we have true, false, and null, where this logical system is going to be essential when handling incomplete or unknown data efficiently. True is going to represent a condition that is met or a statement that is correct. False now represent a condition that is not met or a statement that is incorrect. And we know we now represent a missing or unknown value, which is either true or false, or signify the absence of a value. Here we have example of where the department is known, and this is going to retrieve employees who the department is unknown. So with missing values, we now have can now arise due to the nature of our horizontal and vertical appending. We can now see that horizontal appending is going to be adding rows from one data set to another, which can introduce a null value if the data set do not align perfectly in terms of our rows. Here we have an example. While with vertical appending, whereby adding columns from one data set to another, we're now going to introduce a null value if the data set do not align perfectly in terms of column. So this example might result in no value for salaries if some employees do not have corresponding entries in the salaries table. Also, we have inconsistency between different data sets. When integrating data from different sources, inconsistency can rise due to differences in aggregation level, grouping, and encoding. So aggregation level, which is now going to have different data set, which might cover different level of aggregation. So here we have an example where by combining these data sets, it is crucial to align appropriately, possibly by aggregating individual data to the household level or vice versa. Grouping, we now have different data sets which might group data differently, such as by age, decades versus generation. Dataset A will now group age by decades. Dataset B is going to group age by generation. And also combining these datasets will require aligning the grouping to ensure consistency. Encoding, we now have to look into different datasets which might use different encoding schemes, such as numerical versus alphabetical groupings. We have an example for that. And here we have a summary table of what we've covered so far. So to conclude, we can now say that understanding the three value logic and handling missing value are going to be very important when it comes to data integration to ensure that we have accurate and completeness of the combined data sets. With our merit activity, we're now going to analyze the issues of inconsistency between different data sets and how inconsistency can be overcome. So as we know, when we're now combining data from different sources, we now often introduce inconsistency, which can now complicate data analysis and lead to erroneous conclusion. So we can see that we have, with this document analysis, the key issues of inconsistency between different data sets and explores methods will now include non-SQL approach for overcoming this inconsistency. So the key issues of inconsistency between datasets would be aggregation level, where we now have different datasets which might cover data at verified level of aggregation. For instance, one dataset might contain individual levels data, while another covers household level data. So, for example, a dataset of individual income versus a dataset of household income. Grouping, where dataset might now group data differently. So, for example, one dataset might group age by decade, while another will now group by generation. Encoding, we now look at different encoding schemes which can be used in different datasets. So one dataset might use numerical code, while another one will now include alphabetical code. So the solution for this will now be creating a mapping table to convert between different encoding schemes. Data format, we now have variations in data format, such as date format, currency format, and decimal separators, which can cause inconsistencies. Missing values, no. This might be present in one dataset, but none in another, which will now lead into incomplete data when merged. Solutions for this, we now have to input missing values. We use techniques such as outer join to handle our nodes properly. Non-SQL method for merging data sources. So with non-SQL method, it can now be effective for merging data sources, especially when dealing with text file, spreadsheet, or when SQL is not optimal choice. So by combining our text file, we can now be done using various tools and programming language. And for example, we can now use Python. So here's an example of using Python to combine our CSV files. Combining spreadsheet. This can be done simply by using spreadsheet softwares like Microsoft Excel or Google Sheet. So by using Excel combine sheet, we're now going to use a copy and paste method, where we're going to open the first spreadsheet and select the data that we want to copy. We'll now use Ctrl+C and then open our second spreadsheet and paste the data where we want it to be pasted with Ctrl+V. Also, we can be using Power Query in Excel. So when we have to go to Date tab, we now select Get Data from our file and then from Workbook. So this will now load each spreadsheet we want to combine them. So the use of Power Query is to merge or append queries as we need. So to overcome inconsistency, to effectively merge data set and overcome inconsistency, we have to consider the following strategies. standardization, mapping tables, data cleaning and transformation, aggregation and disaggregation. When it comes to handling missing values, we have to now input missing values or use techniques such as outer join to incorporate null values appropriately. Here's our table summary of what we've covered so far. We presented the issues and we also look into the solutions for each of them. So to conclude, we now know that inconsistency between different data sets can be a very significant challenge when it comes to data integration. So by understanding and addressing this issue through standardization, mapping tables and data cleaning, we can now have a proper handling of missing values. This can be achieved and it can be done by having a reliable merged data set. So you can now see that non-SQL methods such as combining text files or spreadsheet can now provide a versatile alternative for data merging, especially when dealing with diverse data sources. So this was everything for today's session. Is there any question for me?
No, thank you, Victor. That was all really clear. Yeah, really useful stuff. Yeah, no, that's great. Thank you.
Okay. So if this was everything, I'll see you guys tomorrow and have a great rest of the day.
You too, Victor. See you tomorrow.
See you tomorrow. Bye.